What is going on, guys? Welcome to your 17th physics lesson, and in this lesson I want to talk to you guys about Newton's third law. Now, before we get into the law itself and I tell you guys what it is, I want to show you guys this equation. F equals ma, or F ma. Now, obviously what this means is force equals mass times acceleration. Basically, if we wanted to figure out the acceleration of something and we had the force and the mass, we could do that easily by, plugging in the variables, switching things around, calculate that rather easy. So let me go ahead and show you guys a quick example that will help you understand Newton's third law. Say you were standing on the top of a building and you had this big old pumpkin like that. Now you drop that pumpkin so it's falling freely through the air. Now obviously the force in this case pulling the pumpkin to the ground would be gravity, and we could of course calculate the mass of the pumpkin to figure out its acceleration. Now say instead of standing on top of the building, now you are just standing on top of the ground, on top of Earth. So we have no object, it's just you. Now check this out. The force is still gravity. The force is pulling you down to the ground. We could, of course, calculate your mass, figure out whatever that is, but let's go ahead and take a look at the acceleration. The acceleration of you, or the object, is zero. You aren't moving anywhere, even though you have a force and a mass. Your acceleration is zero? Does that make sense? Well, if I just went ahead and I said, you know what, why does that happen? An easy answer would be, well, Bucky, because you're standing on the freaking ground. That's why you're not going anywhere. But Newton wasn't satisfied with this answer, so he needed to come up with this law. And what he said is, the reason that you are not accelerating is because when you are standing on Earth, you do have a force and a mass, but the force of the earth is pushing up on you at an equal force. Now, whenever this happens and the force downward equals the force upward and the object has no acceleration, this is called a force pair. Not to be confused with a force pair, which is indeed my favorite fruit. Now, like I said, a force pair happens when two objects have equal force but opposite directions. So let's just give this a fake force of like 10 newtons gravity, and the earth is pushing up in you with 10 newtons upward. Whenever you have equal forces in opposite directions, then your object is always going to have zero acceleration, aka it's not going to be moving anywhere. So usually whenever I teach this to people, it confuses them how pretty much there is a force keeping you from being sucked down to the middle of the earth, and I don't know, it's, to be honest, physics is kind of confusing, but I think I can help clear things up by showing you guys an easier example. Of course, whenever you're just standing walking around the earth, it may be kind of hard to grasp the concept of a force pair, so let me show you guys this. Say that we have a tree limb, and on the tree we have a watermelon. Now, of course, I know watermelons don't grow on trees, but for this example, this is a watermelon tree. Don't watermelons have like some stripes on them or something? This kind of looks like that loaf of bread or a shoe leg. Anyways, I'm getting distracted. This is a watermelon tree. Now check it out. There are two forces working on this watermelon. First of all, we have gravity. Now gravity is trying to pull this watermelon down, make it fall on the ground. But why is it not falling on the ground? Well, that's because we have another force. That's the tree limb. Now, the tree limb is pushing or pulling, depending on, whose standpoint you're taking, has a force upward. Now, since the tree limb has a force moving the watermelon upward and gravity is trying to pull it down, the watermelon results in zero acceleration. So let's go ahead and give these some fake values of 5 newtons each. So gravity is pulling down on the watermelon with a force of 5 newtons, and the tree limb is holding up the watermelon with a force of 5 newtons. So then the end result, wow, definitely spelled that wrong. Okay, slow down, Bucky. Result is zero acceleration, aka this watermelon here isn't moving at all. So again, like Newton said, a force pair, what you see right here, is what happens when two objects or an object has two forces in opposite directions but of equal magnitude, causing zero acceleration. So, of course, if we wanted to get rid of this force pair, then what we would do is we would take a pair of scissors and cut this tree limb, and then whenever we would do that, the watermelon would, of course, spring or fall to the ground. So basically, like I said, that's the concept behind Newton's third law. And you probably more commonly heard it, like I said, for every action, there is an equal and opposite reaction. So that's the main concept behind it. So hopefully you guys understand it a little bit better, and hopefully you guys understand what a force pair is and why you guys are not sinking to the middle of the earth. So anyways, thank you guys for watching. Don't forget to subscribe, and I will see you guys in the next video.